I'm pretty sure you'll get around 30 to 35 right answers. Because there are at least 18 to 20 easy questions of the question paper, another 18 to 20 the questions which you have prepared well, your easy chapters, from there questions will be there. So that 30 to 35 to 40 right answers if you get in the first round, believe me, in the second round you can put in little more effort because you have already attempted such questions, those questions for another 2 minutes. Put in another 30 seconds or 40 seconds, you'll get another 5 to 6 questions quite easily. So don't waste your time while attempting the questions. Most of the students in the exam, what they do, whenever I speak to the students after exams, the common answer will be time was not enough. Time was not enough because of this. Most of the students attempt the questions in the regular manner until they get the answer. And when teacher says last 10 minutes, I mean after 50th minute, the student will be at 25th or 26th question out of 60. In last 10 minutes, the student has to write another 30, 35 questions. Of course, we don't leave that questions, definitely. But what we do, from there onwards, in the last 10 minutes, we don't even read the question. We just follow some pattern, I mean, do some rangoli in that OMR sheet. A, B, C, D, D, C, B, A, B, C, D, D, C, B, A, without even looking at the question. When I don't read the question, how can I understand whether it is an easy question or tough question? So be very precise, very precise. Timing is very, very important. It is not only how much you know matters in the competitive exams, how you manage that 60 minutes or maybe in JEE that 180 minutes, 3 hours is very, very important. Managing time is most important, and your success based on how well you manage the time. That's the first point. How to prepare? Look at the easy chapters. Prepare well in the easy chapters. And how to write? Manage your time. In the first 35-40 minutes, you should able to complete one round of answering. And keep a minimum target. I told you, most of the students are in the range of 18 to 28 or 30 questions, right answers. You keep a minimum target of crossing 40 or 45. That must be. And that makes a huge difference in your ranking. Believe me, if you cross 45 easily, it makes a huge difference in your ranking. I'll give you one example. I had 2 students around 5-6 years back. A student, a guy having 87% in PUC, and another guy had 79% in board exam. See, there are around 8% difference in the marks. And then at the end of CET, the 87% guy ended up with 17,000 odd ranking, whereas 79% guy ended up with 7,900 or 7,800 somewhere. Look at the difference. It's exactly 10,000 ranks reverse difference. And it is all based on or because of the CET performance. I'll always say the CET performance, CET ranking is most important. I don't say that your board exam percentage is not important. Both are important. But when you compare together board exam percentage as well as CET ranking, definitely CET ranking is most important. If you give some validity period for board exam marks, I feel it is around 10-15 days validity maximum. Because once if your board exam results are out, within 10 to 15 days, your CET ranking will be out. And once if the CET results are out, nobody is going to ask you what is your PUC percentage. Remember that. The only question that comes to you is what is your ranking in CET. That's it. And that is why CET rank has more weightage compared to board exam marks. And all your allotment of seats from there onwards is completely based on CET ranking. And therefore, performance here matters a lot. And performance is completely depends on how much you have prepared, what is the knowledge, subject knowledge. At the same time, how well you have managed your time, and you can manage your time based on the tricks or shortcuts that you are going to use in the exam. That's where the point lies. Tricks or shortcuts are very, very important in the exam. Initially, I give you some general tips. general tips in the sense how I can attempt an exam in general. And later I come back to the very, very precise tips of mathematics. General tips has 5 points I'll tell you. First point, I always believe graphical analysis is most important. Graphical analysis of the question is most important. What do I mean by graphical analysis of the question? Sometimes a question will be very difficult to solve based on analytical method, direct method. Whereas if I try with graphical method, it will be very, very easy for me to get the answer quickly. For example, I'll give you one question. You see, how many values of x satisfy? I'll write the question. How many values of x satisfy the equation? The equation looks like x cube minus 3x square minus x plus 3 equal to e power x plus e power minus x. Of course, by looking at the equation, you understand that how difficult it is. Options are A, B, C, D, 1, 2, 3, 4. Okay. By looking at the equation, I can understand it is not so easy for me to solve this particular equation. Left hand side is a cubic equation, whereas right hand side is exponential e power x plus e power minus x. If I try to solve this analytically, where left hand side and right hand side meet, definitely it takes around 3 to 4 minutes for me. Instead, I'll try to go for graphical analysis. That is what I'm saying. Graphical analysis of the question is most important. Graphical analysis. I'll try to solve graphically this particular question. Look at the right hand side. E power x plus e power minus x. If I try to draw that particular graph, e power x plus e power minus x, at x equal to 0, e power 0 plus e power minus 0 will be 2. So at x equal to 0, it will be 2. At x equal to 0, it will be 2. And now, if I draw e power x plus e power minus x, right side is e power x and left hand side is e power minus x. This is the curve e power x plus e power minus x. Equation x cube minus 3x square minus x plus. So it has 3 roots and the roots are minus 1, 1 as well as 3, which means minus 1 here, 1 here and 3 somewhere here. The curve should pass through these 3 points. When I say curve passes through these 3 points, and if you put x equal to 0 in this cubic equation, x equal to 0 gives you value 3, which means that x equal to 0, it passes through y equal to 3, which means curve will pass through minus 1, it reaches 3, comes back to 1 and goes to 3, like this, the left hand side curve. Now if you see, there are 2 points of intersection here, so answer must be option B. That is what graphical analysis means, where instead of solving the given question analytically, directly, wasting time, you can go for drawing the graph of the equation and identify how exactly the graph behaves. Very quickly you get the answer. So one most important method is definitely graphical analysis. Of course, what is the second point then? Second hint. Second hint is nothing but hit and trial. I'll call it as hit and trial. Of course, what do you mean by hit and trial? Hit and trial is nothing but you just hit at the options and check whether this is the possible answer or not. Instead of solving the question, you hit at the answer and check which is the possible answer. One example I'll give you, it may be a very lengthy question, but still, example you see, second question, given Tn is equal to 1 power 4 plus 2 power 4 plus 3 power 4, etc. n power 4. I think this is exactly plus 1, 2n plus 1 into 3n square plus 3n minus 1. Okay. Option 3, option 4 are similarly n by 30 into something and n by 30 into something. Big equation, big equation. Now, obviously, this question is not such an easy question to directly go for the answer. I want an expression for Tn. You may be knowing this. Sigma n is n into n plus 1 by 2. Sigma n square is n into n plus 1, 2n plus 1 by 6. Like that, you have even got sigma n cube, n square into n plus 1 whole square by 4, etc. These kind of expressions you have got in first PU, and you know how difficult it is to get the right hand side. Now, in this particular case, instead of going for actual method of derivation, hit and trial means I can even try for looking at which option may be the possible option here. Example, I will take n equal to 1 and n equal to 2 for safer reason. N equal to 1 as well as n equal to 2. Then the question becomes, when n equal to 1, T1, only one term, 1 power 4 must be 1. Similarly, when n equal to 2, T2 must be 2 power 4 plus 1 power 4, 2 terms, which will be 17, I think. 2 power 4 is 16 plus 1, 17. So when n equal to 1, question left hand side will be 1. When n equal to 2, it should be 17. Same way, you put n equal to 1 and n equal to 2 in these 4 options. And check which option gives you, when n equal to 1, option should give you 1. And when if you put n equal to 2, answer should be 17. If second option gives me 1 when I put n equal to 1 and 17 when I put n equal to 2, then second option must be my answer. I did not do any simplification work. I just hit at the options and checked which option may be the right answer. So that is most important tips for any subject, not just for maths, for any subject. Sometimes we can knock at the answers and see options and see whether it will be a right answer or not. Very, very important trick it is. That is second one. Third one, of course, we should be very, very thorough with the formulae. Remembering formulae in any subject is most important. Remembering formulae. In maths, of course, it is a lot. You may have to remember many formulae, trigonometric formulae, all identities of vectors should be remembered very well, and many in integration as well as differentiation. Once if you remember the formulae, many cases you can easily get the answer. I'll give you one example. Suppose I have a question like this. What is the limit extending to 0 of, say for example, sine square x by, instead of sine square x, I'll take like this, limit extending to 0 of 1 minus cos x by x square. I'll take this. This is better. If I know that 1 minus cos x can be replaced by 2 sine square x by 2 by x, now the things will be quite easy for me. Once if I know the identity well, 1 minus cos x is 2 sine square x by 2. Now it will be limit extending to 0 of 2. I'll write sine square x by 2 as sine x by 2 into sine x by 2. X square as x into x. Now I'll try to adjust the formula. X by 2, multiply by 2 and divide by 2, and even multiply by 2 and divide by 2. Sin theta by theta form is 1. Sin theta by theta form is 1. 1, 2 cancels, and in few seconds I got the answer to be 1 by 2. If I remember the formula properly, again it will be quite easy for me to get the quick answer. First point was graphical analysis, second was hit and trial, and third is remembering formula. Fourth one, interesting. Many times I use this. Fourth one, it will be intelligent guess. will be intelligent guess. Intelligent guess means we should be able to guess which may be the right answer, or more than that, we should be able to eliminate the wrong answers. Like I should understand that this is not the right answer. This is not the right answer. I'll give you one example here, how to go for intelligent guess. I'll frame a question. Say, for example, question will be the equation of the line which is, for example, perpendicular to 2x plus 3y is equal to 6 and passing through the point 2x plus 3y equal to 6 and passing through the point, say for example 2, 3. Suppose a question is like this and options are given. Option A, 3x plus 2y plus 2 equal to 0. Option B, 3x minus 2y minus 2 equal to 0. Option C, 3x minus 2y plus 2 equal to 0. And option D, x plus y equal to 7. Now, when I look at this particular question, actually I should work out. Instead, whenever I look at the question and I see that my required straight line should be perpendicular to the given line, and any line perpendicular to this must have the form 3x minus 2y plus k equal to 0 because of the perpendicularity condition in terms of the slope. K, m1 into m2 should be minus 1. So 3x minus 2y is plus k. Now I look at the option. I have 3x minus 2y in two cases. 3x minus 2y in two cases. If I am fortunate enough, 3x minus 2y will be in only one case. Say for example, if it is looks like this, then I can say this must be the answer. This must be the answer. Or if it is there in two cases, then I can try one more chance. 3x minus 2y in two cases, I can try one more chance. Put the point, substitute the point. Put x equal to 2 and y equal to 3 and check which option satisfies. X equal to 2 and y equal to 3 and check which option satisfies. If any one option satisfies, I've just framed the question here, so it may not be the right options here, but you can go for substituting the point also. Just substitute the point and see which option satisfies the point and then decide on the answer. So substitution of the given point many times gives us very, very quick answer. Fourth one. Maybe fifth one, you see, fifth one. It is reverse engineering. Fifth point. Reverse engineering means I'm coming back from options to question. Instead of going from question to option, go back from option to question. Check whether this can be the answer or not, or this cannot be the answer, like that. Or maybe substituting the values, put x equal to 2. You check whether question and answer both satisfies. That is reverse engineering, going from questions to option to question. So 5 tips you remember very well: graphical analysis, hit and trial, remembering formula, intelligent guess, and reverse engineering. This will help you in any of the subjects. It may not be maths only. This particular tips will help you in all the subjects. At the same time, when we are very specific on maths now, I'll come back to the very, very important skills in maths now. For example, look at matrices and determinants chapter. So for example, I have a question like this. If f of x equal to, I have a big determinant to evaluate, and it looks like cos square x, cos x sin x, minus sin x, cos x sin x, sin square x, cos x, sin x, minus cos x, 0. This is the determinant. Then f of x equal to, options will be option A 0, option B 1, option C 2, option D none of these. If a question comes like this, and you can just imagine by looking at the question itself how lengthy it will be if you directly go for expansion of the determinant. It is 3 into 3, 3 cross 3 determinant, and also having so many functions there. Instead, when it is said that it is 2 log x, It is true for all x. We can take values for x here. I'll put x equal to 0. If I put x equal to 0 in the determinant, definitely cos 0 becomes 1, and wherever sin 0 is 0, it is 0. My matrix becomes very simple. F of 0 or f of x becomes cos means 1, sin is there, last term sin is there, sin x, yeah, cos x sin is there, sin cos, and sin minus cos is minus 1, 0. Determinant is simplified to a very small determinant, and answer must be this 1 into which will be 1. Option B is answer. Just imagine, hardly 10 seconds we might have used it here. Whenever you have such a lengthy questions, big determinants, which is true for all x, and you have some trigonometric formula or something like that, better go for x equal to 0, x equal to pi by 2, etc. You will definitely get the answers quickly. Next, maybe look at one more question. Like, what is the equation of the tangent to the curve? Equation of the tangent to the curve. Tangent to the curve. And curve is y into 1 plus x square. Y into 1 plus x square is equal to 2 minus x. Where it crosses x-axis. Where it crosses x-axis. And options looks like A, x plus 5y is 2, x plus 5y is 2. B, x minus 5y is 2. C, 5x minus y is 2. And D, 5x plus y is 2. Okay, 5x plus y is 2. I'll tell you graphically what exactly I'm looking for. There is a curve. Definitely it crosses x-axis at some point. I need equation of the tangent at that particular point. Maybe something like this. This is the curve crossing x-axis at this particular point. I can draw a tangent at that point. What is the equation of the tangent? This is graphically how I can understand the question. Analytically, what I should do, first I should find the point. A curve cuts x-axis means what? That means y must be equal to 0. What happens when y is 0? When y is 0, entire left hand side is 0. Then 0 equal to 2 minus x. 0 equal to 2 minus x definitely gives me x equal to 2. Therefore, the point of intersection with x-axis is 2, 0. This is the point 2, 0. I want the tangent at the point 2, 0. And once if I get the point, I know how to get the answer. I want the slope of the curve, slope of the tangent. Slope of the tangent is nothing but a derivative at that particular point. Now, what should I do actually is y into 1 plus x square equal to 2 minus x. I must differentiate, find dy by dx, and dy by dx at that particular point I want. And whatever value I get, I should call it as, slope. And once if I get slope, answer must y1 is this point 2, 0. This is actual process. Instead of going through so much of process, many times what I can do, I'll tell you, as soon as I get the point, you know that point is a point on the curve as well as point is a point on the tangent also. So just to substitute for the options, just substitute x equal to 2 and y equal to 0 in the option and check which option satisfies the condition. Which option satisfies these points. In case if only one option satisfies the point, you are done. Your answer is obtained. That option must be the answer. I did not go through slope at all. I just obtained the point. Whenever you need equation of a straight line, equation of a curve, etc., as soon as you get the point where the equation is required, immediately substitute in the option. If you get only one option satisfying the point, you are done. If you get to two options satisfying the point, then look at the other conditions, maybe slope or something like that. I tell you, you should know the other methods also properly. In this particular case, I'll tell you. If I put x equal to 2 and y equal to 0, first option is satisfied. X 0, y is and y equal to 0, which means I must know what is the slope. Two options are satisfied, other two are not satisfied, definitely, but two options are satisfied. Therefore, I must know, I should get the slope and I should go to the actual method. Whenever you use tricks, shortcuts, etc., at the same time, you can use tricks or shortcuts only when you know the actual methods properly. It is not, I can use shortcuts and tricks for all the 60 questions and I will finish the CET exam within 30 seconds, 30 minutes. It is not true. You should know the actual method and then go for learning shortcuts. I tell you, you know cricket matches. Shortcut or tricks are like reverse sweep in cricket or switch it in cricket. Olden days, it was not there. When Gavaskar was playing 10,000 runs he has got in test cricket, he might not have used reverse sweep even a single time. But nowadays, it is a shortcut to get the runs. But remember, you can hit reverse sweep or you can do reverse sweep only when you know all the other shots properly. Only a very good batsman like Rohit Sharma, Shikhar Dhawan and can play like reverse sweep. Bumrah or Nehra cannot come and play reverse sweep and get boundaries. So shortcuts are exactly similar to that. You should know method properly and then use the tricks. That's it. Now, let us continue. Let's continue. Suppose I have a question like this, for example. If the tangent to the curve, if the tangent to the curve, y is equal to 6x minus x square, y is equal to 6x minus x square, is parallel to the line, 4x minus 2y plus 1 equal to 0, then point of contact is. Options are given to be 2, 8, 1, 4, second option, third option 8, 2, fourth option 4, 1. I'll read the question again. If the tangent to the curve is parallel to a straight line, what should be the point of contact? If I draw this geometrically, I'll tell you how exactly I can understand. Suppose this is my curve, y equal to 6x minus x square. At this particular point, if I draw the tangent, that tangent is parallel to the given line. Given line is 4x minus 2y plus 1 equal to 0. What is the point of contact of the tangent with the curve? This point I'm looking for. Okay, we can do this easily because slope of the tangent should be equal to slope of the straight line because they are parallel. Slope of the tangent is nothing but a derivative, so that dy by dx must be equal to slope of the straight line. Minus a by b is 2, I think, minus 4 by minus 2. But what is dy by dx? Dy by dx is nothing but what is that? Y equal to 6x minus x square. And when y is 6x minus x square, dy by dx must be 6 minus 2x is 2. Which means if I bring this here, 4 equal to 2x, x is 2. Once if I get x equal to 2, I will get y. Fine. I can do like this. Instead, I know that I'm searching a point which is also a point on the curve. So what you do is simply substitute these points in the curve. If I put x equal to 2, 6 2s are 12, minus 2 square is 4, 12 minus 4 is 8. When I put x equal to 2, I get y equal to 8. First option satisfies, so that must be the answer for the question. Check other options also whether any other option satisfies. If second option is also satisfying, then we may have to go for the actual method. Otherwise, if only one option satisfies, definitely that option must be the answer. Whenever you have point to substitute, always use that method, substitution of the points. Now, I'll get back to something interesting in integration. In integration, we have something called by parts, integration by parts. You know the method of integration by parts formula. Integral of uv is u into integral v minus integral of integral v into derivative of u. Suppose I have integral of x cos x. I know how to identify u and v. I means even you know, you have the method of isolate. Once if it is identified, it is u into x into integral v, integral cos x is sin x, minus integral of integral v is integral cos x is sin x, derivative of u is nothing but derivative of x1 dx. It will be x sin x minus integral of sin x is minus cos x plus c. Done. This is what the method is. Suppose if I have x square into cos x, difficulty comes. Because of square, I may have to use integration by parts twice. Because first time what happens, you know, first time it becomes u into x square into integral of cos is sin minus integral of cos is sin, derivative of x, u is 2x dx, x square becomes 2x. Now, this integration again to be performed using uv. That's what I'm saying. If you have x square here, you have to use integration by parts twice. Suppose the question is there like x power 5 into e power 3x. You can understand the difficulty of solving this particular question in CET. I think once you have seen such a question, x power 5 into exponential in CET. You need at least 4 minutes to solve this and get the final answer. Instead, I'll give you a generalized formula here, which says integral of uv with respect to x. I'll write the formula like this: uv1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus minus etc. This is called the generalized formula where u dash, u double dash, u triple dash are successive derivatives of u, and v1, v2, v3, v4 are successive integrals of v. I'll show you how exactly I get easily the answer using this particular method. Suppose I has to integrate x cube cos x. A little complicate the thing, x cube. You know that u is x cube and v is cos x. First term is similar, you do u into v1. U is x cube into v1, integral of cos x is sin x. After that, don't follow integration by parts. Instead, use this minus u dash. U dash means you write the derivative of the first bracket, 3x square. And v2 is integral of v1, integral of sin x minus cos x, plus alternative negative and positive signs. Again, derivative of first bracket, 6x, 3x square. Integral of second bracket, minus cos x becomes minus sin x, cos becomes sin and minus will be remaining. Then plus minus next. Derivative of 6 minus sin x gives you cos x. If I continue further, plus derivative of 6 vanishes, which means integration is over. In one step, you get the entire answer instead of applying it 3 times or 4 times. Remember, it should be like u into integral v. After that, alternative negative and positive signs with derivative of the first bracket. Here to here, it must be derivative and integral of the second bracket. Again, derivative of the first bracket, integral of the second bracket, until derivative becomes 0. When derivative vanishes, it means integration process is over. This can be quite easily used during competitive exams, because you need not to show the method. You need the answer straight away. In one step, you get the answer. This is a very, very important formula, generalized integration by parts for competitive exams. At the same time, we have these kind of questions, most possible questions. Maybe integral 0 to pi by 2, definite integral. Sine square x dx, what may be the answer for this? Or integral 0 to pi by 2 cos cube x dx, etc. I think you know the method of evaluating these integrals. For example, if I take sine square x, method must be you go for substituting sine square, replacing sine square, which is 1 minus cos 2x by 2. Then integrate this. 1 by 2 comes out. Integral of 1 is x. Integral of cos 2x is sine 2x by 2, where 1 by 2 is out. 1 by 2 is out, and then apply the limit. This continues. Whereas if it is cos cube x, it must be replaced by 0 to pi by 2. Formula for cos cube is 3 cos x plus cos 3x divided by 4. And then again integrate this. You will get answer somewhere here. Answer. That much of work is there. Instead, I'll try to give you a shortcut here again. Shortcut is very simple. Whenever you have integral from 0 to pi by 2, it may be sine or cos, both having same answer. Maybe I'll take sine power 7x, or it may be 0 to pi by 2, cos power 6x or cos power sine power 6x. Both will have same answer. In such cases, I start with by taking this as n, for example. 1 by n will be 5 by 6 here. If n equal to 6, n minus 1 is 5 by 6. Then into subtract 2 each from numerator and denominator. 5 minus 2 is 3, 6 minus 2 is 4. Continue the process. 3 minus 2 is 1, 4 minus 2 is 2. And whenever you get 1, so this must be the answer. If you get 1 by 2 at the end. Otherwise, sine power 7 you take, you start with the 6 by 7, n minus 1 by n. Continue the process, 6 minus 2, 4, 7 minus 2, 5. Continue the process, 2 by 3. If you get to 2 by 3, stop there. Simplify this, 3 once, 3 twice, 4 twos are 8 twos are 16 by 35 is the answer here. If this is the case, 3 once, 3 twice, I think 5 pi by 4 twos are 8, 16, 32 answer. This method can be used. I'll repeat the method. You should start with n minus 1 by n and then continue with the subtracting 2 each from numerator and denominator. You will either end up with 1 by 2 or 2 by 3. If you end up with 1 by 2, multiply by pi by 2. 2 by 3 means stop there. Now I'll come back to my question. See, this was the question. Sine square x. Where is that? Yeah, here. Sine square x. I've told you the method. This is the method and you get the answer. Instead, I will use the shortcut. N is 2. When I start with the 2, n is 2. N minus 1 by n will be 1 by 2. And you know that if I end up with 1 by 2, I should multiply by pi by 2. Answer must be pi by 4. At the end, you will get same thing. Whereas, look at this. N is 3. If n is 3, n minus 1 by n is 2 by 3. And you know that whenever you get to 2 by 3, you should stop there. Otherwise, you may have to do half a page. Whereas 2 by 3 is quick answer. This can be used quite easily in definite integrals, especially when sine power n and cos power n comes along with 0 to pi by 2 as the limit. Most possible questions, cos cube or sine cube. At the same time, limits and continuity is one of the most important topic for us because we expect around 3 questions from this particular part, limits and continuity. And all the 3 questions can be quite easily answered. All the 3 questions. If it is more than 3 questions, we are lucky enough because we have a very simple method to answer, which we call as LH rule, L'Hopital's rule or L'Hospital's rule. You might have already gone through this particular rule while preparing for CET, like limit extending to a of f of x by g of x. If this becomes an indeterminate form, I can apply this particular rule, which is applied according to this method. You differentiate the numerator and differentiate the denominator. So remember, it is not u by v, not u by v. If it is again the same indeterminate form, you continue applying L'Hospital's rule. Limit extending to a of f double dash x by g double dash x. Okay. My point is not this. This you have already studied, I know. The point is how to apply L'Hospital's rule effectively in different kinds of indeterminate forms. You should know that. That is the point here. I call it as working procedure or method to apply L'Hospital's rule. Working procedure. You remember 4 very simple points. 1. Whenever you get these kind of indeterminate forms, straight away apply L'Hospital's rule. Infinity by infinity or 0 by 0. Second, you may get a problem with indeterminate form as infinity minus infinity. In such cases, first take LCM and then you are able to apply this LH rule. First take LCM, that to be remembered when infinity minus infinity is there. Third, if you get an indeterminate form of this kind, 0 into infinity, bring one factor to denominator, then apply L'Hospital's rule possible. This is important there, bringing one factor to denominator. Suppose, fourth, I have indeterminate forms of this kind, 1 power infinity, 0 power infinity, infinity power infinity, or infinity power 0, all powers. Whenever you see powers in the problem, you take log on both sides, take log, and then you are able to apply L'Hospital's rule. If you remember these simple 4 tips, directly 0 by 0 or infinity by infinity, L'Hospital's, LH. Infinity minus infinity, LCM, and then LH. 0 into infinity, bringing one factor to the denominator, and then you are able to apply LH. All other cases, power cases, taking log and then applying. I'll give you one simple example here also. Simple example here. You can wind up. It's almost 1 hour. Suppose I have a question like this. Limit x tending to 0 of 1 by x minus log 1 plus x divided by x square. Log 1 plus x divided by x square. Okay. If I put x is equal to 0, denominator 0 means I know that both the terms becomes infinity. And whenever infinity minus infinity I get, look at the working procedure I explained. This is the case. Infinity minus infinity means go for LCM. I take LCM. Simple. Limit extending to 0 of LCM will be x square. Obviously, one x comes here, minus log 1 plus x. Now, if you put x equal to 0, I am in this form. X is 0, log 1 is vanishing, x square. And apply LH here, LH rule. Once if you get back to here, you can apply LH. What happens, you know? Derivatives are very simple, I believe. Denominator is easy, 2x. Numerator, first term 1. Second term log means 1 by 1 plus x. But of no use, put x equal to 0 again, denominator is gone. Numerator, this is 0, which means 1 minus 1. Same case. Apply LH for the second time. A very simple question. Limit extending to 0 of denominator becomes 2. 1 is vanishing. Derivative of 1 by x is minus 1 by x square. Minus into minus plus. So 1 by 1 plus x whole square. Now if I put x equal to 0, numerator is 1, denominator is 2. So remember how to apply L'Hospital's rule. Okay. Hope these tricks will be definitely useful for you. It's almost 1 hour, so we can keep some time for question and answer session also. If any questions you have, you can ask, or you can post your questions as a message so that we can try to answer your questions. At the same time, I'll remind you something. We will be sending a feedback form also through mail. So please reply to the feedback. Your suggestions are very, very important for us. And at the same time, Sahyadri will be continuing similar webinars for physics, chemistry, etc. in the upcoming weeks. So please join to those webinars also. Let us have a contact and let us solve our problems mutually, especially when you have problems based on CET processes. like what are the documents required. Once if you complete your CET exam, then those problems come into picture. What are the documents required for CET counseling, how I should prepare for counseling, etc. Those can also be solved. Such questions can also be solved if you are in touch. So better, we will be in touch. Please reply to your feedback options, okay? Okay, if you have any questions, you can even do like this. You better post the questions, send the messages. We will answer to the particular question to the particular student later. That can be easily done. But please reply to the feedback form, give your valuable suggestions, which will be very, very helpful for us. And at the same time, please join to all our upcoming webinars, especially in chemistry, physics, etc. Thank you.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you.
Thank you so much. Amma.